Hey students, today we're going to talk about reaction rates. So reaction rate is the speed at which reactants are converted to products. And the collision theory plays into the reaction rate because it kind of tells you what needs to happen in a reaction in order for the reactants to convert to products. So reactant particles must collide with each other in the correct orientation. So that's actually kind of expressed in this picture right here. So the reactant's not facing the right way. If you have this molecule hitting this molecule, they aren't hitting in the right way for them to react, and so they'll bounce off each other. Reactant particles also must collide with sufficient energy to overcome the activation energy. Remember, the activation energy in like a reaction like this, it needs to overcome the amount of energy here in order to react. So in this example up here, reactants moving too slowly, even if they hit in the right orientation, when they hit each other, they'll just bounce off and not react if they didn't overcome that activation energy. In the bottom example, it shows you where they have enough energy and they collide correctly. So if they have enough energy and they collide in the correct orientation, they will react and become the new substances. So how can we change the reaction rate? There are 5 different ways to, we'll talk technically about 6 different ways to talk about the nature of reactants. So some substances are more reactive just naturally than other substances. So for example, hydrogen readily reacts with chlorine, but poorly with nitrogen. Also, might depend on the state of matter. So 2 solids won't react, but might react when they're aqueous in water. Concentration. If you increase the concentration, you're increasing the number of molecules, and that increases the reaction rate. So if you can see this picture right here, we have in box 1, we have a lower concentration, we have less molecules. In box 2, we have more molecules. And so this one on the right will react faster. So decreasing it, the concentration, like this one on the left, which is the same thing as diluting it, decreases the reaction rate. The reason why in this box on the right that has a higher concentration, it's going to increase the frequency of the collisions. If you have more collisions happening, there's going to be a higher chance of successful collisions in which they have enough energy and the correct orientation to actually react. A catalyst. A catalyst is a substance that changes the rate of chemical reaction without itself being used up. A catalyst increases the reaction rate by decreasing the activation energy. So this black line shows an uncatalyzed reaction, whereas the red line shows the reaction with a catalyst. So it has a lot less energy is needed for that to react. An example for that would be a catalytic converter in your car. An inhibitor slow down reactions, so they're opposite of a catalyst. They decrease reaction rate. Preservatives in food are examples of inhibitors. Surface area, if you increase the surface area, it increases the reaction rate. Why? Because increasing the surface area increases the number of collisions. So over here, we have a low surface area, and so those red molecules can only react with those blue molecules on the outside, and so there's not as many collisions. But if we were to break up the blue molecules, like over here, these have the same amount of blue molecules as over here. The red molecules can react with a lot more. They're exposed to a lot more of those blue molecules, so there's a lot more collisions. Temperature. Increasing the temperature increases the reaction rate. Why? Because the higher temperature means more particles have more kinetic energy and the particles are moving faster. So if you have a faster speed, you're going to have more collisions, and more of those collisions will be successful. If you have more kinetic energy, those particles will have more energy to overcome that activation energy. So they'll have more, more of them will have a sufficient energy to overcome that. So here's an example. And my question, we're going to do a CAR with this. What rate influencing factor affected the reaction rate the most? We're going to use a CAR to defend the answer. So we have trial 1, trial 2, and trial 3. Trial 1 happened at 25 degrees Celsius with a whole tablet, and then this shows what the reaction rate is. Trial 2 had the same temp, but now we had a powdered tablet, and it had this reaction rate. And then trial 3 had a whole had a higher temperature, had a whole tablet again, and 0.15 mole for the reaction rate. We are actually going to jump to the evidence first before we make our claim. So we need to analyze the evidence. We should include numbers in here. So it looks like we have two things that we tested. Here's kind of like our trial that we are using for comparison. So this is our comparison trial that we're going to use for trial 2 and trial 3. So between when we're going from trial 1 to trial 2, the thing that we changed was the whole tablet to the powder tablet. So we tested the surface area. And it changed from 0.025 to 0.085. So it went from 0.025 to 0.085 when we increase the surface area. So increasing the surface area, this is going to be SA, means it increased the reaction rate by whatever 0.085 minus 0.025 is. So 0.085 minus 0.025, that looks like that would be 0.06. So it increased it by 0.06 molar per second. Now let's compare trial 1 to trial 3, because that also has only one thing changing. This is when we changed the temperature, because the whole tablet stayed the same. So we changed the temperature, and when it went from 0.025 to 0.15. So when we increased the temp, what happened? It went from let's subtract 0.15 minus 0.025. When you subtract that, it increased the reaction rate by 0.125 molar per second. So which one affected the reaction rate the most? This one did. Okay, so now we need to write this into a claim and evidence. So our claim is that temperature affected reaction rate the most. Our reasoning why is because you want to include both of these. So increasing the temp increased reaction rate. I'm going to abbreviate that as RXN, reaction rate, by 0.125 molar per second, increasing the surface area, increased reaction rate by only 0.06 molar per second. So since this one is bigger than the 0.06, it affected it more. Now we're going to use particulate level reasoning for our reasoning. So the reason why it affected it more was because it created, that increase in temp created a faster speed and more kinetic energy. So increasing the temp I don't need a comma, made the molecules travel at a higher speed and have more energy so there would be more successful collisions.